Live from Professor Fudge's quarantine basement, it's 256 Chat with your host, Michael Fudge. Hi, everyone, and welcome to IST256 Chat. I'm your host, Michael Fudge. This week's lesson is on the HTTP protocol and network programming in Python. And I have with me a very special guest, my IT guy, Nick. Nick, how are you?
Great to be here. Thanks for having me on, Fudgy. Gotta get those kids to stay off that Xbox and that PlayStation. They're hogging way too much internet bandwidth for my liking.
Sure, Nick, that's fine. Hey, why is Python such a great choice for network programming?
Well, Fudgy, you see, Python's super easy for performing tasks over a network, like doing HTTP calls over a web API, doing web scraping. It's also super simple, super easy to do some TPT, TCP, and UDP port scanning, as well as just socket connections with your basic TCP and UDP sockets. Hey, Fudgy, that reminds me of a time when you...
Okay, Nick, let's save that story for another time. Seems like network programming is a great choice in Python, and maybe we should just get on with the lesson? All right, let's do that.
You're welcome, dude, and stay off Netflix.
Okay, all right, guilty. I will. Let's get on with the lesson. Hello there and welcome. I hope you enjoyed my IST 256 chat. I'm going to be doing those for the rest of these lessons. We have basically 4 more lessons left in the course. If you look at the syllabus, we have this week, which is Lesson 10, HTTP Protocol Network Programming. Then we have Web APIs, which is really the second half of the first lesson, Lesson 10. And then Pandas in Lesson 12, and Lesson 13 is Data Viz. Then from there on out, it's just doing stuff with the project. All right, let's dive in to the lesson this week. As usual, if you want to ask questions during the lecture, you can use Teams, which the link is right here. And there won't be any participation because this is a pre-recorded lecture, but that would normally be the poll right there. Now, one thing that's different about this lecture than the other lectures is there's no Zybook reading for this. I made my own reading. It's right here. This reading is broken out into 2 parts. The first week, you'll do parts 1 and 2, and then the second week, you'll do parts 3 and 4. All right, let's get started. So in this particular lesson, we're going to look at how the web works, how to make requests, that is, simulate what a web browser does, but use Python to do it. And then we'll look at HTML responses, and we'll also look at JSON responses. We saw last week before spring break how to parse JSON in Python so that it's usable and easy to discover. And we'll continue with that lesson because it's a very important facet about how to make Python do significant things, especially with the web. Then we'll call some APIs. Basically, we'll call a geocoding API and we'll call a weather API this week. Then next week, in the second half of this lesson, we'll get more into calling sophisticated APIs that have different types of requirements. So let's start out class, as we always do, with a connect activity. The Python module to consume a web API is called, is it API, requests, HTTP, or URL library? Pause the video if you'd like to think about the answer, but I'm going to go right into the answer in a second. Okay, the answer here is B, requests. So requests is the library that we will use to call web APIs. So let's review some HTTP. I know you've probably seen some of this in IST195, but it doesn't hurt to sort of go back over it again. When you type in a URL into your browser, you're making a request. And the site processing your request sends you a response. So when you type in www.google.com, you're asking Google for a resource. Google then returns the resource back to you as a response. And then your web browser then uses HTML as content to draw the page. So part of the response has a status code, and the status code tells you what happened. Usually it's a success code, but there are times when you'll get error codes. When you program against the web, these become more important. The browser handles a lot of these things for you, so we don't see them. So HTTP is a text-based protocol, and it is stateless, meaning that every request is independent of the other. There's no connecting, and then you have a session, and then you do multiple things, and you disconnect. It doesn't work that way. So let's do a quick example, then we'll get into some of these request verbs and things like that. Let's just jump out here to a browser, and I'm going to go to the Syracuse website. And you see it loads a page. Now I'm going to bring up the browser tools, which is on my computer. It's F12. The F12 key does this. And if I go to network here again and I reload it, you'll see that it is making a request to several pages to retrieve content. And these are all the things required to make the page go. There's some pictures. There's some scripts. There's some layout or style files. And if I take some element of this page, like here, and then I say inspect, it will jump into the code and show me where that layout is in the HTML. So I can see that this is the particular place where it's showing that text that I highlighted and hit inspect. So that's all great. If I go to the network tab here where I loaded all of these files, you'll see that they all say 200. One of them says failed. They all say 200, and 200 is a status code that says success. So that means that the request worked. Now, the types of requests I'm making here are called gets. Gets are used to retrieve resources, but there's other ones. There's post, put, and delete. Post is used to send data. Put is also used to send data, but it's mainly used for updates. And then delete is used to remove a resource. Now, when you're browsing the web and looking at web pages, you're not really doing more than gets and posts. But when you use HTTP as an API, some of these other verbs come into play, as you'll see. The responses you get back are numbered, and any number that's 200 is success. So 2, 201. They all have different meanings, but anything that begins with a 2 means it worked. 3 means you ask for something and it's no longer there. It's somewhere else, so you're getting redirected to where the resource is. 400 means you made a mistake. As the client, you made the mistake. And 500 means that the server made the mistake. So the error you get back gives you an indication as to who did the wrong thing. So let me sort of demonstrate that now a couple of ways. Let me go back here. So there's a website called HTTP bin. And it's a great website to see sort of how these things actually occur in nature. Because most websites hide away the fact that you're doing something that's going to cause an error. So let's do some status codes here. Like, for example, let's do the response. Let's do a get. And then let's ask for a 300. Let's do a 400. So let's do codes 400. And let's see what we get here. Execute. And if you look, now I got a 400 status code. See that? Right there. So I can ask for a 200. Execute. and then I get a 200 status code. So this is showing you in the network panel of the browser what's actually happening. So this is just a way to sort of simulate all the different facets of the HTTP protocol. It's a very useful way to do that. So let me do an example of just doing a get. Like, so I'll go to HTTP methods and let's just do a get. And let's try it out and let's hit execute. And so there's my get right there. And you can see this is the response that I got back. And the response is in JSON format. See that? So at some point we will consume this in Python, just to show you how that works. So let's remember this URL here. In the meantime, let's go and do another example to start. So in this first example, let's just use requests. So let's import requests. If you want to know all the documentation on requests, you can find that here. I'm going to put that in the notes so that you have it. How to use Python requests. It's a great library for invoking the HTTP protocol in Python. Okay, so I imported requests. Now let's use it. So let's go to a web page here. How's that one? Now, when you use requests, you do something like this: requests, and then what type of verb am I going to use? I'm going to use a get, because I want to get resources from that web page, from Siri to you. I want to do a get, and I want to get that URL. Now, when you run this, it gives you a response 200, which means, response code 200 means it worked. So you might be wondering, well, what's in the response, right? So if I were to go and assign this to a variable, like if I said response, you can call it whatever you want. You're starting to get that with variables, but you want to give them a meaningful name. So let's rerun this request. And then in the response, let's just type in response. Let's type in dir response. What can we do with response? I got to spell it right. I got to spell it right here, too. Response. And then response. And if you go past all the hidden ones, down here you'll see that there's an OK, there's a status code, and then there's text, and then there's also JSON. So we'll take a look at all of these. So let's try this. Let's say response status code. Should say 200 because it worked. How about response OK? That's true. How about response text? That's the web page. So this stuff, this is the contents of the web page. It's the exact same thing that your browser receives to draw this. To draw that. Exact same thing that you are seeing here, but the browser is rendering the markup in a way that we can appreciate. This is the same markup in the way that Python can appreciate, because Python can actually do something with this if we were to program it to look for words or tags in here, for example. So let's try this. Response JSON. Now this is not in JSON format, so this will give you an error, JSON decode error, because it cannot decode this into JSON. So let's try another example that we can decode into JSON. This request from HTTP bin, right? So this get right here is what we want to do, the request URL. So let's grab that, and let's go down here and do URL. Well, you don't have to call it URL, but I'm just going to, And response requests get the URL, and then let's say response text. And you'll see that it's a string, and it is a string in JSON format. So because it's in JSON format, I can use the JSON function of requests to convert this into a Python object. So I'm just going to call this data. And then let's just go down here and type in data again. So now it's an actual Python object. This is no longer a string, it's a dictionary. If I ask, hey, what's the type? Well, I better do it down here. What's the type of data? It's going to say you're a dict, right? And that means you're a variable with keys and values, right? So the first key is called args. The second key is called headers. So let's go in, let's grab this origin, right? See this origin? Let's not grab that. That looks too easy. Let's grab host, right? So it's under the key headers. So we would say data headers. And let's see what we get first. Okay, and I get another dictionary, and that has all these keys in it: accept encoding, cache control, and then I go down, and I think what I wanted was which one did I want? Let's go with host. Headers, host. There. So there you go. Now you might be wondering, big deal, right? But let's go back and do this again with response text. Let's just say raw data is response text. So I'm not going to turn this text into JSON. And then if I go raw data, now how do I get out the host? That's all on me. You know, I might have to do, this is a string. So now I got to do something like raw data find the word host. Okay, it's at position 140. Okay, but what I really need to do is find the colon after the host. So let's try to find this. It's going to get ugly, folks. And this is why parsing it to JSON is so much better. Okay, so then now that I found that, then I have to go and look for this comma after that. So then it would be, you know, raw data find the comma starting at position 139. That's at 160. Then I can ask for a substring, you know, between these values to extract that out. That's butt ugly, folks, and not very useful. It's better to convert it to a Python object and then just traverse the keys in the dictionary like that. So much easier. Okay, that's what I want you to see, is that if I want to try to retrieve out the same thing, http bin org, now I got to do something like this. Raw data, and let's slice it, and we're going to start at slice 139 plus, how many characters are in this? 1, 2, 3, 4, 5, 6, 7. 139 plus 7. And then we're going to end that slice at 160. Oh, I'm pretty close. I still got, you know, I got some garbage to clean up in here, but I'm pretty close. But you can see how ugly and awkward that is, and it's so much easier to get it this way. And that is the point. Now, you'll notice that when we did this up here, we didn't have to do what we did last time we used JSON, which was import JSON. But I could do this. I could import JSON and then say, you know, JSON loads and then response text. And that does the same thing as just doing response JSON. As a matter of fact, response JSON, this function JSON that was written for you as part of the Python request module, it does exactly this. So you don't need to do all this importing of JSON. It's just included in requests. It's one of the convenience features for you. So this is really handy, and it makes it super easy for us to make a request over the web knowing that response is going to be in JavaScript object notation format, and then allowing us to decode that to a Python dictionary so that we can easily traverse that dictionary to find what we're looking for. And this is the magic that makes using Python the language of choice for consuming web APIs. Okay. So let's do another check yourself. Pause the video here while you consider answering this. The HTTP response code for success is which one of these? Well, you know that success begins with one of these numbers. 5, 4, 3, 2, 1. Which one is success? C, 200. Any code that begins with a 2 is a success code. Okay. There's lots of ways that we can send data to a website over HTTP. Now, if you look at this example that we didn't send any data to this website. We just said HTTP bin, let's just get something. And we didn't give it any data. But there's ways you can send data to a website. You can put it in the URL. For example, I can call some API and then say user 45. And that's going to make the assumption that I'm looking for data for user 45, for example. You can also put it on what's called the query string, which is a set of key value pairs that come after the URL. So there's a question mark. And then after that, I put the keys and values. So user 45, user equals 45. So that's called the query string. Can also put it in the header. When I put it in the header, I'm making a dictionary of keys and values, and then those get sent with the request in the header of the request. And I can also send it in the body of the request. But when I send it in the body of the request, I can't use a get. I have to use a post. So post is a different verb, and that request verb, as we learned before, there's 4 request verbs. Right, there's get, post, put, and delete. Post is a different verb, and it allows you to send large data payloads as input. So one way I can send data to a web server is by using a post and then putting the data in the body. So which approach do you use? It depends on how the service was written. This is going to be governed by the way that the server that you're trying to consume resources on was designed. How about a couple of examples now using HTTP bin? Let's do a couple of examples just to show you sort of how this works in practicality. Let's do a get in the URL, then we'll do a get in the query string. Then we'll do a get in the header. We'll do all of these examples just to give you an idea how this works. All right. So again, why am I not using a real website at this point? Why am I using this toy website called HTTP bin? Well, the reason I'm using the toy website is simply because at this point, I do not want to introduce the complexity of what a real website is doing. Okay, and the real website you go to ask for the data, that website is going to have an opinion as to how you are going to communicate with it. With HTTP bin, we can try all sorts of different ways, and that way I don't have to show you 4 different services. Okay, we'll save that for next week. So let's do HTTP bin again. So let's make a URL here. It doesn't have to be called URL. Let's just call it U1. And let's make this HTTPS HTTP bin org get. And now I'm going to use a query string. I'm going to say name is Mike and age is 48. Okay. And let's make the request. And I don't have to call it response. I'm going to call it R1 for response 1. So let's invoke that request, get back the JSON. What you get back in the JSON oh, I'm not seeing any args in here. Well, I should be seeing args. Interesting. Huh. Funny. I should be seeing... No, I see what I'm doing. Classic knucklehead move. I'm making the request and I'm putting it in R1. And then I'm saying response JSON. It should be R1 JSON. See, you know? Okay, there we go. So now it took what was on the query string and it parsed it into arguments. Okay? So I'm going to make this same request over and over again, but I'm going to make the query string different ways. Okay? So here I am making a dictionary for the query string. So I'm going to call this query string, and let's have name Mike, age 45, and then I forgot to quote right there. And then let's do U2 get, and then we're going to say R2 is request get. Let's get that URL, but let's pass in now the parameters on the query string. This is my preferred method of doing this. And then let's do this. R2, let's print R2 URL. And then let's do R2 JSON. So see what it did is this is my URL, and then this is my query string dictionary, and then when I make the request, it builds the query string for me. See that? It's the same as this one up here. Well, I typed in 45 instead of 48. I lost 3 years. Yay. But this is more advantageous because you don't have to manually create this query string, which can be problematic at times. So why not just do what you can do well in Python, which is make a dictionary. If you make the dictionary wrong, right, it's going to give you an error. So if you make it this far and it runs, then you know it's going to generate the right URL for you. Okay, so that's sort of the point of doing it this way. This is my preferred method of using a query string, is to make a dictionary and then pass the dictionary in with the params named argument. How did I know to use params? If you get help on request get, or you go up here and you read about request get, you'll learn about it. So if you go down here and read about request get, you can learn all about it there. It's in the docs, as we say. Let's do an example of using headers now. So let's do this. Let's call this header, and let's put, usually what you put in the header are things like API key information, authorization tokens, things like that. So I'm going to put a header and I'm going to call it API key. And then the value is going to be whatever my API key, which is usually some crazy long thing. Usually you get this from the service that you're using. And now I'm going to make the same requests make the same GET request, but now I'm going to send in not parameters on the query string, but some headers. Okay, and then let's do an R3 JSON. All right. Let's see, where's my header? So it says headers, and then there's my API key. See? that information I put into the header. So what is the header for? The header are variables, they're keys and values that tell the server, the web server that's receiving your request, sort of how it should manipulate or tweak your request based on who you are. One of the more common headers is called the user agent. And the user agent gives the web server an indication of what web browser you're using. So you notice when you query Python with requests, the user agent says Python requests. So the web server knows that we're not Chrome or Firefox or Edge or Safari. We're not one of these browsers. We're actually using Python to make the request. We're not a web browser. We're a Python program, and it knows that. What it chooses to do with that is up to the web service. Okay, let's do a post. So here's an example of a post. So for a post, we need some data. So typically, I call the data the payload. Payload. And let's just say this is some data that I want to send. Whoops. To your web server. And let's do this. U4. Let's do a post. And we're going to do a R4 request post, not get now, with U4. Now we have to send it the data, and the data is the payload. And let's do a response JSON. And what we'll get back is, whoops, I got to spell this right. http://bin.org. There. So if we look, oh, it's not response JSON, it's R4 JSON. I made the same mistake before. Now, in here, you'll see that there's the data that was sent in the response body of and that's my payload. So there and there. Now you might be saying, can you combine all these together? And the answer, of course, is yes. And for the sake of brevity, I will just get it all in here. I'll pause the video, get it all in here, and then run it. Okay, through the magic of pause videos, I was able to type it all in. So on the first line here, I have the query string. On the second line, I made the header. These are both just dictionaries. On the third line, I just made a string of all the data I want to send it. I'm doing a post. And then I'm doing a request post. The data I send in is the payload. The parameters I send in is the query string. And the headers I send in is the header. And then I run this. And you can see that here's my data. There's my parsed query string. And in my headers, I have an API key. So it all works. And you can combine all these bits together. So you might be saying, well, why? Again, it depends on the service that you use. The web service that you're going to want to call for whatever it is that you do in your projects is going to have a different set of requirements for being invoked properly. And you have to be able to understand how to do each of these bits. It may require something in the query string and something in the header. It might require you to do a post and put something in the header, for example. So knowing how to do all these is really, really important. Okay, let's do a check yourself. What URL is printed on this last line? So if I have parameters like this on line 1 and headers on line 3, remember headers do not appear in the query string, but the parameters do. So I shouldn't expect to see a C in there. So that rules out C as a choice and A as a choice. All right, now with that, I'll give you a minute to try to figure it out. Pause the video. So the answer should be B, right? just A and B are the parameters with values 1s and 2. If I run this, you'll see that that's what it does. Okay, cool. All right, let's get into it and call a real API now. We're going to call the OpenStreetMaps geocoding API. What the geocoding API does, these are a class of APIs I call base APIs. You need this API to use with other APIs. For example, you want to draw something on a map, you need to take data and convert it to a GPS coordinate, because most mapping softwares require GPS coordinates, latitudes and longitudes. So what the geocoding API does is if you give it a street address, it will give you a latitude and a longitude. So how do you call this API? Well, here's an example of the URL that you would use to call the API. You see it has a query string on it, and then it says Q equals address. Q address is the address that you want to search for. Okay. So, and then this is the data that you get back, and it is JSON formatted data. So let's give it a whirl. Let's give it a whirl. I'm going to go over here and take this URL. You don't want to watch me type that. And let's just do this. URL. Now, I don't want to do this with my query string. That is uncool, in my opinion. I don't like to manually build my query strings. I like to build them out of dictionaries. So I'm going to do params. And we're going to do the key Q. And then in here, I'm going to put in whatever the address is. And I'm going to make that a variable. And then I'm going to have the key format. And then the format I want back is JSON. Okay. And now up here, I'm going to say address is, let's do 314 Hines Hall, Syracuse University. Syracuse, New York. Let's get the GPS coordinates for that. Okay, so we're going to say response requests get the URL with my params equal to the params variable. So that's my named argument. That's my variable. I use the same one. Okay, and let's, for sanity check, let's print response URL. This is usually how I like to start my web APIs. Run that. I get a link. I click the link. It tells me exactly what OpenStreetMaps does with the link, and I get no data back. So it cannot find that. Let's manipulate this a bit to maybe get a little luckier. Okay, so it did find Hines Hall. What it doesn't find is 314 Hines Hall, so it can't find my office. OpenStreetMap isn't that good. But the nice thing about OpenStreetMap is the word open. I could go in there and add that location if I want. All right, so that's sanity check number one. Before you code against an API, you probably want to print your request and invoke your request within a browser to see what the heck happens. All right, so let's just change this to Hines Hall. And let's try this. Okay, so there's the data I get back. Now that I get data back, I can try to parse this data in JSON. So let's say data response JSON. And then let's just take a look at data in this cell here. Now I want to get to these latitudes and longitudes down here. So how do I do it? Well, this square bracket means it's a list. Now there's only one thing in this list. So I'm just going to grab data 0, right? Now I've got a dictionary. So there's a key called place ID. There's a key called bounding box. There's a key called lat. So let's data 0 lat. There's the latitude. And then here's the longitude. Data 0 lon. There's a longitude. So there you have it. I took that address and I got a latitude and longitude back from there. So that's basically how you get that done. So let's, this is useful. Let's turn it into a function, right? So to make this into a function, what we want to do is we want to send the address in as input. So any address comes in as input. Then it does this. Then it returns this. Now, what's kind of cool is I think what I'll do is I'll return this as a tuple, okay, which is a nice thing that you can do in Python when you want to return more than one thing. I'm going to demonstrate how to return this as a tuple. So let's write this as a function. So I'm going to take all this code here, and I'm going to put it down here, because normally I would edit this, but again, I want to show you, like, I want to keep all this stuff so that you have it as you're going through and reviewing this yourself. So to turn this into a function, I want this to be input. This is the thing that's going to change every time. Like maybe I want to search for Mount Rushmore. Mount Rushmore. All right? And then there it is. And then if I do data, there it is, right? And you can see there's multiple places here, but we're just going to go and take the first one. We're going to assume that the first one is the one we want, always. We're just going to make that assumption, okay? So it still works. Let's write it in code now. So I'm going to say def geocode, and then I'm going to pass in the address. That's going to be the input into this function. I'm not going to give it Mount Rushmore. I'm going to give it any address. Okay, then I want to do this. 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 I guess I don't need to do the print anymore, but it's useful to have it in there for now. And now what I want to do is I want to return data 0 lat and comma data 0 long. So I can return two things together. This returns them as a tuple. It returns one thing, but they're just a pair. They're a pair. So now we can try it like this. I can say lat lon geocode. Let's geocode carrier dome. See what happens. And then let's print lat lon. Okay, there's the latitude and longitude of the carrier dome. Let's use my favorite verification service, Google. What is the latitude and longitude for the carrier dome? 430362. 430362. 761363. 761363. The minus means west. West. Pretty sweet. It works. Nice. Now, it doesn't handle any errors. But again, the handling of errors is the responsibility of the program, of the code that uses this function. That's the code that needs to handle the errors, not necessarily the code itself in here, unless there's some error you need to catch in here and do something else before you actually return lat and long. But that's not what we're doing here. Okay, one other thing we might want to do. This is great to geocode. Let's rename this geocode to lat lon, because that's kind of cool. Geocode to lat lon. All right, still works. Let's write another one that does a more generic geocoding, because you can also use geocoding to find the city and state for a zip code. So let me kind of show you how this rolls off the tongue. Let's do a more generic geocoder that looks like this. Def geocode And then we're going to just slap in here, you know, any location. Doesn't have to be an address. And then it's going to pretty much follow the same results as this, except it's just going to be not an address. It's going to be just some location. And then it's just going to return the data. We're not going to mess around trying to figure out what we got back. Okay, this is a more generic geocoder. So watch what you could do with a more generic geocoder. You could do something like this. You could say zip code is 13244, and then you could say data is geocode that zip code. The zip code. And then let's just take a look at data. All right. We get a list, right? And you can see that this is some zip code that is not in our country. It's in Saudi Arabia. And then this one is in the United States. So you might say, well, I wanted the one in the United States, right? So let's try this, 13244, and let's put USA in here. All right, now we get the first one we get is United States, right? So what I might want to do now is retrieve out of here the first. So that's this one. And let's just get the display name, right? Okay, so there we go. 13244, Syracuse, Onondaga County, New York. Let's try another one. Let's try 601, Chicago. Or we can try 90210, Beverly Hills. Yeah, it's pretty cool, huh? So that gives you an example of another way that you can use a geocoder, right? And again, you get a lot of data back here. And anything that's in this output of the data, you can find a way to use it, whether you're using the latitude or longitude, whether you're using the postcode, whether you're using the display name. It doesn't matter. Any of the data that's in here that you want to use. There's a bounding box, which is a rectangle that sort of bounds where that address is valid, or where that input that you gave it is valid. There's lots of things that you can try to use here. Okay. All right, let's do one with some weather forecasting. So let's take a look at darksky.net. And then we're going to combine this together into a single program. So if you go here to darksky.net, you'll see it says Dark Sky API, try for free. So I have already signed up many times, but you would go here and sign up. I have done this, so I'm just going to log in. I think it's... I always forget what I used. All right, hold on a second. Okay, after multiple attempts, I finally got in there. What you'll notice here with Dark Sky, it's a weather forecasting API. And to make it work, you need to issue a latitude and longitude, and then it will return back the weather at that location as a JSON data set. See that? So in here, eventually I can find, partly cloudy, and the temperature is 44 degrees. Okay? So, knowing that, what else do you need? You need to give it a secret key on the URL. See that? It's part of the URL, this key. And this key is generated when you log in. And you need to put it on the URL so that they can credit the number of requests you're making to your account. See, it says your trial account allows for 1,000 free calls per day. If you'd like to make more than calls, you need to pay for it. So this is how a lot of APIs work. You get some for free, but not all for free. So I will reset my secret key after this demo is over because I don't want the entire internet using my key and hitting my credit card. Although I never did put a credit card in for this particular service, but you get my point. You should always protect these secret keys because you don't want to run into a situation where someone can abuse your account and then you get held responsible for that abuse. So this secret key has to go on that URL. So I'm going to copy this URL here. Copy. And let's go back to my code here. And I already had a zip code for the carrier dome up here. So I'm going to paste in my URL here. And we're going to do some editing of this URL. I'm going to take this latitude and longitude and put them down here. And it says you have to separate them with a comma. And let's try to print this. And let's see if we get a link. And this is, it's 35 degrees and cloudy. And that's what it is today in Syracuse, New York. Okay? So it looks like it's pretty accurate. Let's write it as a request. So it's going to look something like this. We need to have the key, right, which is right here. There's my key. You want to separate that out as a variable. And then you need to have the latitude and the longitude, which I'm going to do those right here. So this one's a little different. It doesn't have a query string. It's all done on the URL. So how do you deal with these ones that are on the URL? The ones that are on the URL are pretty simple. You use an F string. So you'd say URL equals F. And then here is where the key goes. Here is where the lat goes. And here is where the long goes. There you go. Print URL. Get the same URL as before. Why am I breaking out into variables? Because eventually I'm going to make it into a function, right? It's always a good idea to use variables because variables vary and they introduce variability into our programs, which make them more reusable. Now that I've got a URL, I can do my requests, right? Response, requests, get that URL, response, JSON. Let's see what we get. Okay, there's my JSON data. And in here, you can see there's a currently, and then that gives you information about the current conditions. And then there's a key called minutely, which gives you a minute-by-minute set of conditions. Then in here, I believe there's a forecast. Here's the hourly one. And then somewhere in here, I think, if you just go down far enough, there is a forecast. Let's see. Daily. Yep. So this is the 7-day forecast. Okay. All right. So let's get the current conditions. So that would be under the currently key. So let's just put it in a variable. Let's call it weather. And then let's just say weather currently. And there's a dictionary of all the goods about the current weather. Okay. That was pretty simple. Let's wrap it up and write it as a function. So this key here, I could make it global. Generally, the way I like to do this kind of stuff is I would make this global and put it at the top. That way I can just replace all my keys easily. I know it violates one of the rules of building a function when you do that, and I'll explain that. But this is a very good case for doing that. Okay, let's write it. Def get weather, get current weather, and let's put in a lat and a lon. And we're going to do this. we'll keep that print in there for now, and we're going to return that. Now, you'll notice there is no key in here. There's a let and a lon come in, but where's the key come from? Well, key is a variable outside the function scope that I'm using. This is usually frowned upon in most programming languages, but in Python it's fairly acceptable, especially in the notebook environment where you might want to have these global variables like API keys and stuff that you want to have at the top so you can easily change them around. Okay. The way you'd probably write this in every other programming language is you would put it inside the function like that. Okay. So I guess what I'll do is I'll stick with that approach. And then I'll just have to remember to change it in 2 places when it's over. Okay, now after we write our function, we test it. So let's do conditions, and let's say get current weather, and then let's pass in these lat and long from before. How's that? And then let's print conditions. There you go. So 42 and overcast, cloudy. Okay. So looks good. So I've got that one function up here, geocode to lat lon, and I've got this other function down here, get current weather. Now we might want to try to mash them up into a program, into a single story. I think that's what's coming next. So let's do this. Let's write a program that you input some landmark location, and then it will output the weather forecast, the current conditions at that location. Let's not do the forecast. If you want to do the forecast, it's really just retrieving a different key out of the API output. Like I said, if you go down far enough, here's the API output. Oh, that's the OpenStreetMaps one. If I go here, this is the current conditions. This is the conditions minute by minute. That's the hour by hour. And here's the daily one. So this will give you the 7-day forecast. If you wanna do that, okay. We're gonna do that. But there's a lot of rain in the forecast. I'm looking through here. I see a lot of rain. Rain. Yuck. Welcome to spring in Syracuse. Okay. Let's write this program. This end-to-end example, then we'll be done with class. All right. So I already have a lot of my functions already written. I'm going to take these functions that I wrote, and I'm going to I know it's bad form to do this, but I want all of this to be in one spot. So there's one function. There's the other function. Right? Okay. I would probably have a cell here that said import requests. Okay. So now all my code's in one spot. Now I'm going to think about how I'm going to use these functions to accomplish the task. Let's think of our algorithm first. So back in here it says input a city-state combination like Syracuse, New York, then output the current weather forecast at that location. Handles errors. Also probably wants to use a loop. All right. So I'm going to change this to a markdown, and let's write our algorithm. So something like this probably makes sense. While, let's just say loop. And then what are we going to do? We're going to say input a location or type quit. If quit, exit loop. Geocode location to lat long. I'm not handling any errors at this point. Never do that. Get something working, then figure out what breaks it, then write more code to fix what's breaking it. That's the right approach. Geocode to lat long, get current weather conditions for lat long. And then print current weather conditions. That's it. Okay. So I'll first write it without the loop, then I'll write it with the loop, because there's no point. Whoops. Yeah, I don't like when it does that. There's no point in actually using the loop till you know it works once. Okay. So let's just go for it. So let's type in location. And to start, I'm not even going to input a location. I'm just going to put the location in there. Let's put in Miami, Florida. Okay. And then we're going to say lat long is geocode to lat long, that location. See, I'm calling the functions that I wrote up here. So, I used a process by which I first built these functions, and now I'm using them to solve the problem down here. Okay, this makes it a little easier. Problem simplification, right? We build things, and then we reuse the things we build. Okay, that's one way to solve the issue. Also, when I write this program, I'm not introducing the loop yet. I'm, again, using problem simplification because I just want to get some code to work. Then when I get that code work, I'm going to feel groovy and funky about that. Then I'm going to try and write more code. Okay, lat long location, and then conditions, get current weather at lat long, and then print conditions. We'll make this better later. This is good enough for now. So in Miami, it's 76 and clear. Let's go find out by asking my friend Google. What is the current weather in Miami, Florida? 78. Mostly cloudy. What do we got here again? It says clear. And 76. So that's pretty close. Pretty close. All right, if you want a more accurate answer, you should probably ask dark sky, right? So if I go to dark sky but don't use the API, so like I'm just going to go to dark sky like this. Whoop. Ah, boy. Dark sky. And let's put in Miami, Florida. $77 and clear. That's what it said. So at least it's accurate with itself. Maybe Google's more accurate. I don't know. Okay. So here's our basic program. Not great, but better. So let's make it better, right? Rather than print conditions, let's print out a story. Let's say print this F string. And the F string I want to print is going to say at, well, let's just say location. So Miami, Florida is, and I want to say partly cloudy or clear, which is summary. Summary. How about the current conditions at location are conditions summary and conditions temperature degrees. Okay, let's try that out. Let's not print conditions anymore. The current conditions at Miami, Florida are clear and 76.6 degrees. Very sexy. I love it. Okay. Now it's printing these out here, and these are kind of bugging me, so I'm going to actually turn those prints off. I'm just going to put little pounds in front of them to comment them out. Then I'm going to rerun these cells because I'm pretty confident these functions work now, so that now when I run this, it just goes, the current conditions at Miami, Florida. Okay, very cool. So now let's make this into a loop. So I don't want to have Miami, Florida. I want to input, enter. So again, successive refinement. I wrote the program once, made it simple, just made sure it works. Now I'm going to actually unleash the hounds and use an input. Enter a location. How's that sound? Or quit to stop. Okay. If location quit. Let's do location lower. Break. Now I can put this all in a loop. While true. There. Enter location. Quit to stop. Syracuse, New York. Oh, got an index error. Index out of range. All right, so I hit my first error. So it's probably because I didn't type in Quebec right. That's all right. Let's run it again. Let's try something. I'm trying to find someplace. Let's do... okay, let's try Mount Rushmore. Let's try London, UK. Okay, so it seems to be working. Quit. Pretty neat, huh? You mashed up a service. You mashed up two services to make a useful program that uses the internet. Okay, this program doesn't work if the internet's broken, which is fine. Okay, but it's pretty cool. You know, ultimately the whole, the beef of it is these 7 lines of code, but up here there's some more code, right? But still, I mean, you accomplish some amazing things in 7, 14, 15, 22 lines of code. 22 lines of code to make this work. You can't do that in any other programming language. It's amazing what you can do in Python. So let's handle some errors now. So let's run it and type in that, and I get an index error. And I get an index error when I'm calling geocode. See that? So what's happening here is it cannot geocode that, and it's giving me an index error. So let's catch that. Try this. Now, if I try it here and it hits an accept, the program's going to stop. Do we want the program to stop? Probably not. So what I want to do is I want to try it in here. Try that stuff. And accept index error. This is why you always catch your errors after you get the program working, so that you know what the legitimate errors are. Okay. And let's say, what are we going to say here? Print I could not error. I could not find the location. Let's make this an F string. Location. There. Let's try that out. I could not find the location. It seems to be working. Let's try this out now. Montreal. I think it's QC, right? Yep. Okay. But if I type in Montreal QB, it says I can't find the location, Montreal QB. But we can now try this. Let's try 90210 USA. The current conditions at 90210 USA are clear and 45.11 degrees. We can also try this. Oh, that's weird. I thought those were the same place. I guess not. Huh. Well, you know, our geocode, it's not our fault, it's our geocoder's fault, right? We're probably not using a good geocoder here. But it does work, seem to work for most situations. Let's try. Yeah, seems to be working. Key West, Florida. Yeah. Brownsville, Texas. All right. So it seems to be working pretty good. So what kind of other errors could we possibly have? We could have an error where we give it geocodes to a location, but there's no weather there, right? But we haven't encountered that error yet. I wouldn't even know how to make that error happen. Antarctica. See, it just tries to figure it out, right? So, you know, works pretty good. So basically, that's it. Now, are there other errors that can occur? Yes. Do you know what they are at this time? No. Should you try to catch them? No. One error that might occur is if your Wi-Fi is off. If your Wi-Fi is off, you're gonna get an error. But you know, if your Wi-Fi is off, you're not running this Jupyter notebook anyway because you got to use the internet to get to it. So these are things that you don't have to necessarily worry about in this particular situation. Okay. All right, let's conclude with an exit ticket. So which HTTP method is used to send large quantity of data on the URL? Is it A, get, B, post, C, delete, or D, put? So I'll give you a second. And of course the answer is B, post. All right, that concludes our lecture for this week. And we'll bring this back to the fold next week as we look deeper into different ways you can call different types of APIs. We'll also explore the vast array of APIs that are out there for you to use. And hopefully this will start giving you a better idea of the kind of things you might want to do for your project, for your programming project in this course. Okay? Thanks. We'll see you later. Bye.